Hydrogen usually has an oxidation number of +1, simply because it belongs to group 1. Yes, when we're speaking about elements that have fixed oxidation numbers, you could see that hydrogen was in group 1. Yes, we've already discussed that. It usually has an oxidation number of +1, but sometimes its oxidation number can be -1. -1. That means hydrogen can have variable oxidation state for some reasons, and that's what we'll be discussing in this lesson. So hydrogen can have oxidation number of 1 because it has lost its electron, so oxidation number of +1. It has lost its 1 electron. Or it can gain an electron to become -1. So it has gained an extra electron. So +1 or -1. But why? Let's look at that real quick. Suppose hydrogen is bonded with chlorine to form hydrogen chloride. You know, actually, although we said earlier the hydrogen will lose its 1 electron to become positive, the truth is it doesn't actually lose the electron. Yes, it doesn't actually lose its electron because hydrogen and chlorine go into bonding. What type of bonding? It is covalent bonding. Covalent bonding simply means that the two elements involved are not willing to lose their electrons. So they just come together and share the electrons they have donated. So they donate the electrons to each other and then share it. So hydrogen and chlorine will overlap and then they both share the electron. So you can see that hydrogen brought the blue electron and chlorine brought the black electron. Then they shared it. And it looks as though hydrogen is now satisfied, chlorine is also satisfied. But here's the point. You see the electrons that they are sharing. Funny enough, chlorine is much more electronegative than hydrogen. Simply means that it is so strong that it has a strong affinity to the electron. It loves to draw the electron. So the chlorine will pull the electron towards itself. So as a result, the hydrogen tends to be as though it is positive. It tends to be as though it has lost the electron, and then the chlorine becomes more negative. Although they are sharing. As an analogy, think of it this way. You and a friend who eats a lot contributed maybe 10 cedis each to buy a pack of rice. So he brought 10 cedis, you also brought 10 cedis. But he eats more than you do. Although you contributed equal amount of money, do you think you are going to eat equal amount of rice? The simple answer is no. Why? Because he eats too much. So he will eat more than you will. Maybe he will eat 3 out of 4 of the food, and you are going to eat just a quarter of it. Why? He eats more than you do, although you contributed the same. So chlorine is much more stronger than hydrogen. So although they all contributed the electrons and they are sharing it, chlorine will now pull the electron towards itself, thereby distorting the electron cloud around the hydrogen chloride and pulling it more towards the chlorine. So hydrogen, in this sense, will have an oxidation number of +1, and chlorine will have an oxidation number of -1. So in this situation, where the hydrogen is bonded to a highly electronegative atom, then in that case, hydrogen will have an oxidation state of +1. So examples of those highly electronegative elements or atoms are chlorine, oxygen, nitrogen, carbon. So chlorine, oxygen, nitrogen, carbon. When hydrogen bonds with any of these elements, hydrogen will tend to be a +1, simply because these atoms pull the shared pair of electrons towards themselves. Now, what about if hydrogen is bonded to metals? If you look at the elements I mentioned earlier, oxygen, chlorine, nitrogen, carbon, they are all non-metals. What about when hydrogen is bonded to a metal? Metals are highly electropositive. For example, sodium. Sodium, more especially the group 1 metal, sodium has an atomic number of 11 and it has 1 electron in its outermost shell. So it is even eager. It wants to lose that 1 electron. It doesn't want it. So sodium will lose that 1 electron and chlorine will now, and hydrogen will now gain it. So in this sense, hydrogen will become -1 because it has gained a lost electron. So sodium and hydrogen now come together to form sodium hydride. So to put it simple, when hydrogen reacts with highly electronegative atoms, they tend to be positive. For example, carbon, oxygen, nitrogen, fluorine. But if they bond with metals like sodium, calcium, and lithium to form the hydrides, the metal hydride like sodium hydride, lithium hydride, then in that case, it becomes -1. So here's the special rule. Hydrogen have variable oxidation state. It can be +1 or -1, depending on the element it's bonded with. But the trick is when you see it bonded with oxygen, carbon, fluorine, nitrogen, then know that the oxidation state is +1. But if you see it bonded with elements like sodium, calcium, lithium to form the metal hydrides, then know that the oxidation state is -1. So keep that in mind. As we move on to our next lesson, we'll be looking at the oxidation state or the special rules of, oxygen. See you in our next lesson. But before you go, don't forget to subscribe to the channel. See you in our next lesson.